Hello and welcome. In this video, we're going to talk about the data analytics lifecycle. If you've been regularly following our channel, you'd realize that we did another video called Data Analytics for Beginners. In that video, we covered definitions of data analytics, types of data analytics, and some use cases, along with why it is in so much of demand. In this video, we intend to take a closer look at how a data analytics project is executed. Again, this video is meant for beginners, so we will try to keep it as simple and as jargon-free as possible. Let's get started. Cross-industry standard process for data mining, in short, CRISP-DM. It's a de facto open standard for developing data mining and knowledge discovery projects. What do we mean by open standard? An open standard is a standard which is available to the general public and has been developed in a collaborative way. So there is not one single person who can say that it's his contribution alone. When a new practice is being evolved, you may not have a ready reference from a book to look at it. Therefore, what happens is the standards are developed in a collaborative way. The researchers get in touch with the teams across the globe who are working on similar projects, and they try to understand what is the best practice. And that is how a standard is derived over a period of time. So CRISP-DM, or the Cross-Industry Standard Process for Data Mining, is a de facto standard for developing data mining and knowledge discovery projects. But wait a second, didn't I mention that this video is about data analytics? Let's understand how these two are related. Data mining is the practice of examining large pre-existing databases in order to discover or generate information. On the other hand, as we've already seen in our previous video, analytics is the science of using data to build models that lead to better decisions that in turn add value to individuals, companies, and institutions. So if you see, these two, data mining and data analytics approaches, are related to each other. Therefore, when it comes to an approach towards data analytics, we can leverage upon the existing foundation of data mining and take it forward. Coming back, there are 6 steps involved in this standard approach, starting from business understanding, data preparation, modeling, model evaluation, and model deployment. Now, you must be able to see that there is a back and forth movement in certain cases. Therefore, it is not necessarily that you only move in one direction. There are steps which are interrelated. End of the day, when you take up a project, it's very important that you keep the business interest in mind. And as you continue to make progress through the steps, there has to be certain checks at all intermediate steps so that you ensure that your direction is consistent in line with the priorities of the business. We will spend time understanding each of these steps. Let's just start with business understanding and data understanding. When we say business, for convenience, let's try to replace this word with engagement. What I mean to say is, business is nothing but the kind of engagement that you're going to have with a person. Let's get introduced to a person called Bob. When you meet him for the first time, what all information you think you will be able to gain about him? If you're just meeting him over a casual chit-chat, you'd probably get to know about his name, of course. You will get to know about his profession, what does he do, his organization, where does he work. Maybe you'll be able to guess, or maybe you will be able to understand about his education, his age, origin, where does he come from. Now let's just see if the nature of our engagement with Bob changes. Here we were talking about a person meeting him in general. Let's say Bob wants to take admission in one of the top B schools. He's a working professional and he wants to further go for higher education. What all would the school be interested in knowing about Bob? Of course, the school would be more interested in the eligibility checks before it offers admission. So school would want to check his age, his test score, how he performs in the entrance exam, academic performance, the past performance, and maybe in certain cases his performance in an interview. Now let's refer to another nature of engagement. Let's say Bob applies for a job. Now wherever he applies for a job, that organization would want to know about his experience, his expertise, what kind of projects he has undertaken and all. And of course, interview performance matters. And they'll also be concerned about his stability. So everything is fine, but if the person is not stable, there's no point hiring that person, right? Let's refer to another engagement. Maybe it's a bank. So if Bob applies for a loan, the bank would be interested in his credit history, his rating, his income, existing loans, how much does he owe to others if at all he has other loans, and how much balance does he carry forward each month, the average monthly balance or things like that. Now let's just say Bob wants to enroll for a health insurance. The insurance provider needs to decide the premium. And how would the insurance provider go about doing so? Of course, they'll look at certain attributes. So they would want to know Bob's age, how many dependents does he have, his medical history, his test reports at the time of signing up, and whether he's a smoker or a non-smoker. These are just some examples. Let's say you are a retail store, a brick and mortar retail store in the locality where Bob lives. What all pieces of information you would be interested in knowing about? Well, you might be interested in knowing about how many times does he visit you every month, how much revenue is generated through his purchases, category of products that he likes so that you can send him appropriate promotions, what has been his response to the promotions in the past, and what is his level of satisfaction so that you're certain that you're keeping him happy and he keeps coming back to you. Just pause it for a second and think. Depending on your nature of engagement with an individual or an institution, your data requirements change. If you are a bank, you need certain specific data points to be able to make wise decisions. It wouldn't suffice if you know a person only at a general level and sanction him a loan. For all you know, you might never get your money back. Similarly, if you are a smart retail store which believes in the growing competition, you definitely want to get a better hold of your customers. Again, targeting your customers in a general way is not an option. We've come across a lot of people. The moment they hear the word analytics, they think it's about some fancy algorithms. It's about coding. But trust me, coding plays a role much later in the scheme of things. Much before that, you need to have a good balance between your business understanding and the kind of data that you'd be looking at. Because if you go wrong here, your model or your coding is really not going to help you anywhere in the flow. Therefore, it is pertinent for you to get a good grab of business understanding and ensure that you have relative data elements available with you. Only then you'll be able to come up with the right set of recommendations for your business. Let's just move ahead. So now that we've understood what is our business priority, what kind of data we should be looking at, let's move to the next step called data preparation. Now, you'll be really lucky if you already have the data available in the right shape as you need it. In most of the cases, data preparation is the most time-consuming exercise in an analytics project because the data comes from multiple sources, depends on how it is captured, how it is compiled, and therefore there might be certain opportunities. The common opportunities that we've experienced are issues related to the completeness of the data. So we'll have to check if we have any missing values in the data, and if so, then we will have to go ahead and impute them. Imputation means finding out the appropriate value which can be put in place of a missing value. Consistency issues. Are the variables being classified and labeled consistently? Say you have people punching in the data in their systems. There could be opportunities associated with their own understanding of the data. So there could be inconsistencies. Presence of outliers. If you've seen our videos on central tendency, you would know that outliers are the extreme values which influence the central tendency called mean or the average. So if we have outliers or extreme values present in our data, they need to be thoroughly investigated. Presence of redundant variables. Are we collecting variables which are redundant? For example, if you have monthly income as one column and next to it you also have annual income. Now in most of the cases, this monthly income rolls up to the annual income, or an annual income divided by 12 gives you the monthly income. So there is no point keeping both the variables in your model at the same time. If you have redundant variables in your model, you would want to decide whether you want to keep them or eliminate them, and which ones to eliminate. Interestingly, in an analytics project, whatever we've covered so far takes roughly about 70 to 75% of the time. I repeat, it's 70 to 75% of the time in an analytics project that you will devote will go towards business understanding, data understanding, and data preparation. The remaining portion, which is modeling, model evaluation, and model deployment, takes not more than 20-25% of the overall time. One more task to perform before we actually build the model. That is called data partitioning. Let's assume a bank has given you a consulting assignment. Bank has given you historical data of 1 million customers. For each of these customers, you know the correct decision whether a loan was approved or not approved. And that is the correct decision basis bank's own experience with those 1 million customers. Bank knows whether the bank should have or should not have approved a given loan for a customer. This is the wealth of information the bank is giving you. Now, the bank says that we want you to create a model in such a way that we are able to correctly predict whether we should approve or not approve a loan. If this information is given to you, you don't just utilize all of this at once. Instead, you partition this data into two parts. So you take 70% of the data and call it the train data. This is the data that will be utilized for building a model. And the remaining 30% of the data, which is also known as the test data, is used to validate the model. Now, why do we need to partition it? Simple analogy. If you are a brilliant student, your strength is not only to solve the problems that have been given to you in the book or for which you already have solutions. Your strength shows up when you are able to apply what you learned from the book and solve the problems that you've probably not seen before. Likewise, in this case, we are partitioning the data into two parts. 70% of the data will be known to the model as we'll be using this data to make the model. But 30% of the data is something that the model has never seen. So if you do good on a data that you've never seen, that means that you are really good. The next question could be, why on historical data and why not on the real data? The answer is simple. Before you go ahead and expose your model to the future transactions, it is imperative that you validate the goodness of your model on the transactions that have already been closed, for which you already know what should have been the correct outcome. That way, you kind of reduce the risk that you would have taken otherwise by just exposing the model to future data or the transactions which are yet to happen. Now let's just understand the kind of tasks that we try to solve through modeling approaches. It all begins here. Y is equal to fx. Y is an output or an outcome of interest which is being predicted using x's. What are my x's? These are my inputs. Let's just talk about our example of Bob availing a bank loan. The bank wants to know all the right inputs before it sanctions a loan. What are these inputs? These were his credit history, his existing loans, his average balance carried forward, and many more. All of these put together help us come to a conclusion whether we should approve a loan for Bob or not. First, we need to ask ourselves what kind of problems are we trying to solve, and then accordingly we take the approach. One could be that we are trying to predict an outcome. And again, there could be two branches, classification and regression. In classification type of problems, we are trying to answer questions such as, should we hire or not hire a candidate? Should we sanction or not sanction a loan? So it's a yes, no, or maybe a multi-class decision that you have to take. In regression type of problems, you're trying to do a value prediction. Example could be, how much loan amount should be sanctioned? How much revenue are we likely to generate from a customer? So here you're referring to an outcome of interest, which is a value. The other set of problems that we might want to solve would be trying to understand the patterns in our data. For example, customer segmentation. So what all customers form a cluster? Why do you need to know that? Because you no longer want to have a blanket strategy. You will have customers who are very regular to you and contribute to a high amount of revenue share. Whereas you might have customers who are very regular to you, but they do not necessarily contribute to the same amount of revenue share. Their likings towards your products might be different. A high-value customer might go for a different set of products which are not that popular among the customers who buy low-value products. So you do not want to have a blanket strategy now anymore. You want to have proper customer segmentation in place, and you want to target each customer separately to be able to obtain maximum gain. You could also be facing dimension reduction problems. You need to take a call on whether you need all the variables available, all the x's available to you to predict a y. There could be certain x's which are more important or critical compared to the others. So the ones that are not that critical might conveniently be dropped. Please understand that the purpose of taking the x's here is not just to build a model. The business eventually is going to rely on these x's to be able to better control the y. That's the takeaway. So we want to have x's which we can closely monitor and control so that we get the y that we are interested in. That's why you don't want to prepare a laundry list of x's. You only want the x's which clearly outweigh compared to the x's which are not so important. You will see that the first set of questions are solved by the techniques known as supervised learning techniques, where you always have an outcome of interest or a y value, whether it's a classification or a regression type of problem. In the second set of questions, you would have unsupervised learning techniques put into practice. In simple terms, these do not necessarily have a y, but you're trying to understand the underlying patterns of the data, which are not so clear when you just look at the data or glance through the data. At this stage, you have already made a model, and now it comes to model evaluation. Let us just recollect. In our example, the bank had provided us the complete data of 1 million customers with an outcome of interest which was already provided to us. Those transactions were closed, and we knew what should have been the right result, whether a loan should have been sanctioned or not sanctioned. For each row, for each entry, we know the right answer. We had smartly partitioned the data into two parts. In the 70% of the data, we used all the inputs, x1, x2, x3. These could be the same attributes that we talked about the banking example. We put these x's in this equation y is equal to fx to come to our predicted values of y, which is our outcome of interest. Now it's a time to do a face-off between the observed value, the real right results, versus the predicted values. For demonstration purpose, we've only taken an example of 10 cases. The second column here represents the observed values, the right decisions, and the third column or the last column here represents the predicted value, which is as per the model. Next step will be to do a comparison. For each record, we know the reality and we know the prediction. So if a transaction should have been approved as per the bank and our model has also predicted an approval, it's a match. If it is something that should have not been approved and our model is also in consensus, it is good. But wherever there is a mismatch, that is when a transaction ideally should have been approved but we are saying otherwise or vice versa, we have a problem. Please remember that all of this validation is happening on the test data. And we discussed the logic earlier itself. So now if we want to comment on the accuracy of the model, it is very simple. It is the total correct matches divided by the total opportunities. How many times in this example? Let's say there are 6 matches and there were total 10 opportunities. So we'll say that the model is 60% accurate. You'll present this outcome to your client. If the client finds it good to go, you will go ahead with the deployment. So deployment is mostly the output. This is how you experience. You do not necessarily know all the time what's going on in the background. You only experience the outcome. So let's say now Bob goes to a bank. He meets a bank representative, provides the information that's critical as per the algorithm, as per the model that we've made. He provides his credit history. He provides his income, existing loans in terms of amount, and average monthly balance. All of this information is obtained by the bank representative who punches this into his system. In the background here, your model is in action. So when these pieces of information are passed through the model comes up with an outcome. If everything goes fine, the bank sanctions a loan. So this way, you've seen how an analytics project flows. It's pretty logical. You start with the business understanding. You look for the right data that needs to be made available in line with the business priorities. You clean up the data because the data is not given to you in an ideal format. You have to prepare the data, partition the data, build your model, validate your model, and finally deploy your model. This completes the entire analytics lifecycle. Hope you like this video and it gives you a better understanding of how an analytics project is executed. If so, please subscribe to our channel if you already have not, and hit the bell icon so that you continue to receive updates from us whenever we upload a new video. And most importantly, knowledge gets multiplied when you share it. If you like this video, please share it with all those who might benefit. You will see that when you share something good with others, you get something good in return. Feel free to do so and keep following us. Thank you for your time.